Here's now the whole situation. This car failed with 76,000 kilometers.
It failed with 64,000 kilometers.
Okay. 64,000. So this is what your engine looks like with 64,000 if it is very well maintained. Means every 10,000 kilometers an oil change.
Yeah.
Okay. Next one. This is Vera's engine, which never failed, but we did a premature engine rebuild just to see what the condition is. 260,000 kilometers.
Yeah.
You can see that there is a very even wear. The engine ran half of its lifespan with 5W30. The other half it ran with 5W40. Now, if we compare that with the one we have in the shop right now, 135,000 kilometers on the clock here. So half the mileage from Vera, basically, running on 5W30 with poor maintenance. Now check out the bearing wear. Here, let me turn this one around. This one is even more worn out than Vera's. Poor maintenance and oil dilution will kill those engines.
But what I also see in that wear pattern is that the wear on the bearings happens in early stages, in the early kilometers.
During that phase where the vehicles are maintained in a Land Rover workshop only after 24,000 kilometers. That's when the bearing wear happens. After that, somebody else takes over, the second owner, and then the frequency will go up. So you're absolutely right.
Yeah.
They get screwed up in that basic maintenance period. So this is a pretty good history, and it shows you if you don't do your maintenance properly, you will limit the life of your engine. What I know now for sure is that my SDV8 engine, the bearings look exactly like this. 100% for sure. Why would they look any different? That car has medium maintenance history, okay? So every 25,000 kilometers, it got an oil change. Sometimes spread out to 28,000. So what I got in there now is 8 bearings looking just like that. That's 100% for sure. So does every one of you who has that kind of a maintenance on his vehicle. Every 24,000 kilometers, this is what your bearings look like. Just look at them really nicely. This is what you drive around with. So do I.
Yes, but Christian, mine looks the same with 270,000 kilometers. I'm not worried.
I'm not saying that these bearings will fail, but it clearly shows that they are not at the beginning of their lifespan.
No.
Okay?
No, it's a bathtub effect. You know, the wear happens in early kilometers and then it maintains until it fails. I got a comment today that a guy wants to buy a 441,000 kilometers old Discovery 3 and he asked if he should worry about the crankshaft. The crankshaft is the least of your problems, I'm going to have to say. The bearings and the crankshaft will last until that car finally dies. All your electrical gremlins and the air suspension and the rust and the parking brake and everything, that's what you have to worry about and that's what you have to be willing to deal with.
Yeah, that's exactly right. So, and your bearings look way worse than this. That's for sure too. Did poor maintenance kill our SDV6 or was that a design fault from Ford? That's what we want to talk about in this video.
Hope you enjoy the video.
I know everybody goes now, oh, it's a design fault and the engine sucks and it's always gonna break. Yes, in most cases, it's the design fault which captures that engine early in its lifespan, okay? It's the crankshaft snapping in half. But there are also a lot of engines with a completely different failure mode, where it is not 100% clear if it is a design problem from Ford. And that's the topic of poor maintenance. And we want to talk about that. This is our December 2015 SDV6 Gen 2. That's basically the EU6 version with AdBlue. That's the 3-liter Ford diesel engine which they put into the Discovery 4 until it phased out. Later on, they still kept on using this engine up until today in various different vehicles. For example, the Range Rover Sport, the Range Rover Velar, the regular Range Rover. They also put this engine in a slightly different variant in the 2018 Ford F-150, for example, in the Lariat with the 3-liter diesel Powerstroke. So you find this engine in quite a lot of different vehicles. Jaguar uses it in various vehicles. The engine was also used by Citroën in the early days when it came out, but they phased it out. And we're going to go through various different failure modes, what that engine suffered from early days until now. And many of those are caused by design flaws, but not all of them. And that's what we want to take a look at now.
We have a problem, Christian. We are so crazy.
Yeah, this is not called a problem. This is called a fetish.
Yes.
You know what? I actually gonna wear my Ford jacket when I...
Yes, look what I found in our attic.
Okay, look. And this is not purchased, okay? I earned this one.
Yes.
I was working in the Ford Ypsilanti plant in 1998. And a guy named Rick Spengler, who was the project engineer from Ford back then, gave me this jacket upon completion of the job. We installed a starter motor test line for doing a load test and a freewheel test. So this is well earned. Okay?
Turn around, Christian.
Yeah.
Oh, look at that.
1998, okay? And I still look skinny in it.
Yes.
Now we have basically 3 different crankshafts out of 3 different eras of that TDV6 engine here in front of us. They all have suffered a severe engine failure, but completely different failure modes. So I think that's a good opportunity to go through that. And we'll start with the first one. This is a 2.7 liter TDV6 with the 190 horsepower out of Fabian's Land Rover Discovery 3, which was a 2009, and he suffered a severe bearing failure. That was very common for the early Land Rover Discovery 3s because they had a weaker oil pump than others. I'm not talking about the casting issue where it snaps off and causes a severe engine failure. I'm talking about the oil pumps which have a thinner rotor. They only had like a 13.5 millimeter rotor, and later on they got upsized to 15 millimeters. And that cured a large number of the engine failures, and it improved it a lot. And whenever you had a main bearing failure on these engine blocks, they tended to spin the main bearings around in the block, wasting basically the main bearing tunnel, and then it needed remachining and rehoning, and it was very difficult to fix. A very annoying failure mode. Most people thought then it's because the bearings don't have those little notches to keep them from rotating. We don't want to go into that. These people who think that they are basically wrong, even if they were added later on, it doesn't stop the bearings from rotating. Those notches are only there for the installation process to make sure the bearings sit in the correct position. They have not the task of keeping something from spinning when they seize up. Now, a little bit down the road, we bought a Land Rover Discovery 4 with a failed engine, and the owner said, the vehicle just locked up on the Autobahn. The engine went like from full RPM down to nothing, and he coasted on the side of the road. And he said it must be that snapping crankshaft issue everybody knows about who's driving a diesel Discovery 4, okay? You kind of have that fear in the back of your mind that your crankshaft may snap any second. That's just going with you all the time, okay? This was a purely snapped crankshaft. That issue is clearly a manufacturing defect from Ford, which they never got really under control. It even happens in late model vehicles up until today. They did small revisions on this crankshaft over the years, trying to improve this, but they never really succeeded. Because at the same time, they got more and more horsepower out of that vehicle. This one already had 440 Newton meters of torque. Here they went past 600. I think some of them have like 640 or 660 Newton meters of torque. The engine is known for exactly snapping at this position here. And ours is like a perfect sample, because when we took this engine apart, the thing was just lightly jammed up in there. It just took a couple of hits with a hammer to get it out. And you can watch the entire repair of this SDV6 Discovery 4 in a very detailed series here on our channel.
So, by the way, that crankshaft snapped at 64,000 kilometers.
Yeah, that was a really low mileage one. You can have that same failure at 150 or at 180. I even heard of some cases with 30 and 25,000 kilometers. This failure mode had nothing to do with lack of maintenance, okay? This vehicle was perfectly maintained by the previous owner. In fact, I got the bearings from the connecting rods right here from this engine. They did not suffer any damage whatsoever. They were not even the coating worn through. When you look at the bearings from Fabian's engine here, that engine was not as good maintained, okay? And it had 180 when it snapped. You can see it was fully worn through here.
Yeah.
That's a clear sign that this engine was not as good maintained. It had low oil pressure and it was running 5W30 over its entire lifespan until it died. It also was chip tuned.
Which we do not do.
So this is the very well-known failure mode. We already made a video about this. That just happens. There is nothing you can do. It's that time bomb you drive around with.
It's a 2% chance.
Vera said. In the latest version of the Discovery 4 SDV6, they installed the DEF fluid. So the EU6, which runs AdBlue. They call this engine the Gen2 engine. The Gen2 engine suffers from a big end bearing failure, so where the connecting rod is mounted, and not from a main bearing failure. So back in the early days, we had main bearing failures because of low oil pressure. And I find that very interesting. And at first I thought, well, that's a rare case. We're the only ones who have that now because the car was driven by idiot, all the stuff what you think when you get a bad engine. But no, it's not true. When I started to Google for a replacement engine, I found at least 5 or 6 ads in eBay where people trying to sell their completely failed engine blocks to other people for 699 euros. I don't know for what, but maybe for making a coffee table, because these blocks are wasted when that failure mode happens. So I know instantly that is not a unique failure mode. What basically happens is the engine block develops a little hole here on the side. And that's not good because it rinses all the water out and debris can get in and also the oil comes out. The way this hole gets in there is basically by the connecting rod main bearing seizing up on the crankshaft, and then it splits open the bearing cap. And then this thing is slapping around and all loose, and the crankshaft hits it with the main pin, and then it knocks it here out of the side of the block. So when you get this engine, this connecting rod is somewhat sticking out here.
Mm-hmm. Yes.
Fairly obvious even for Toyota drivers that this is not good. For the Toyota drivers who watch our channel, okay, Land Rovers do that, okay? This is not the same as when you run out of gas and you have to fill yours back up and you're doing an oil change after 400,000 kilometers with 20 W50. This is different. This bearing failure is completely different from this bearing failure. Here we said it was low oil pressure. Why did this bearing failure mode, got skipped over certain years from the Discovery 4 and then it came back? And the reason is it came back with the Gen 2 engine. And to understand this problem, we have to look what's the difference between the Gen 1, which was running the 3-liter from like 2011 up until 2015, and then the Gen 2 came out and it started to have these bearing failures on the big ends. The Gen 2 engine is the EU6, and in order to reach EU6 level here in Europe, they had to reduce the fuel consumption of this vehicle. That reduced the emissions, and this way they could get that label EU6, so we can still drive it in cities where an EU5 is no longer legal. So that's the motivation. In order to sell the vehicle, lower the emissions, get the EU6 sticker, have people driving around and buying the car. And reducing the fuel consumption, it's always the same method in the automotive industry. You reduce fuel consumption by either reducing the weight or by increasing the efficiency of the engine. An increase in efficiency is typically done by reducing friction or by reducing any kind of sources which eat energy. They did not really do much to make the Discovery 4 lighter. It actually got a little heavier, but they did get the car to reduce the fuel consumption quite a bit with the Gen 2 version. And one of the primary things they did is they fumbled around on the oil pump. Okay? The oil pump of the Gen 2 has a connector to it. An electrical connector, okay? Versus all the oil pumps before did not have that connector. Now, what is this, what they did here? They hired someone from BMW, most likely, okay? And asked them, hey, how do you guys do that to reduce your oil pressure under certain instances so that the oil pump does not eat so much energy? And they said, well, we have a solenoid valve somewhere in our engine block and we control that by the ECU, and it can open the flow or reduce the flow. And by that, they can basically control the oil pressure in, let's say, high and low, okay? It's not like all analog. Typically, an oil pump is directly connected to the crankshaft, and when the crankshaft increases speed, the oil pressure increases. When the crankshaft reduces speed, vice versa. But in some use cases, you drive around with a vehicle, you want to have decent oil pressure, but you want to have very low engine RPM, and that's when you have a little bit of a conflict. For example, when you go off-roading, you drive around with high engine loads at extremely low RPM, and you don't want to have there low oil pressure. You want to have a higher oil pressure. So you would typically design your oil pump to deliver at low RPM a fairly decent high flow of oil, so a high pressure. And that's contradictory to the fact when you idle your engine that it has a low consumption. That's when they got the idea, well, let's install a solenoid valve right here, controlled by the ECU, so we can differentiate between idling of the engine and low RPM driving under high load, for example, rock crawling. That's exactly what they did here. They installed this solenoid valve to be able to increase and reduce the flow rate of this pump so that they can adjust between the use case idling and the use case low RPM under high load, but still keep the overall energy consumption of the pump low. And what can happen in one of the failure modes is that the solenoid valve gets actually stuck in the low flow range.
What?
I found language about this in the internet, but I did not find any proof. So I don't know if it's true, if the solenoid valve can get stuck, but the oil which is drawn in here is basically coming directly out of the sump. So if your sump would have a certain amount of chips in it or any kind of contamination which got in there over time, it is theoretically possible that this solenoid valve gets stuck in the low flow mode range, okay? It's basically controlled in a fail-safe mode. So if you would cut the wire off, the solenoid would go in the high flow mode and your vehicle would always have high flow. I do not recommend to cut those wires, okay? Everything I know in theory, and I don't know if that's really like this. I had to translate that out of an Italian manual using Google, okay? That's one of the major differences of that oil pump, that they installed the solenoid. But there is another lesser known thing what they did to improve the oil pressure of this engine block. And yes, I said improve. On the Gen 2 engine block, you have this hole. Isn't that amazing? That hole?
Sure, the other ones do.
The other ones do not have this hole, okay? What this hole is, it's basically the main oil gallery drilled through from the front of the oil pump, okay? So you have the main oil gallery running here straight through the engine block. There's actually that little freeze plug on the back side.
Yeah.
Okay, to close it up. That's when they deep drilled it. And in this engine, they drilled it all the way through to this face. And then you have the cross holes to the bearings, which are here, drilled and mating up with this main oil gallery. So why did they do this? Somebody had a really smart idea, or they understood a certain problem and they wanted to take care of it. And that is, with this oil pump, you have a pressure control valve installed somewhere here in this mechanism. I show you on this one, it's the same one. The pressure control valve sits just about here where also the solenoid valve sits. Mm-hmm. And what that does is when you run cold oil, it will restrict the maximum oil pressure to 4.5 bars. So under cold conditions, your oil is very thick and it develops a lot of oil pressure and it eats a lot of energy. And you have to restrict that pressure from blowing up certain openings in that engine block. For example, the freeze plug on the back of this oil gallery, or develop oil leaks on regular gaskets, which are just not rated for a higher oil pressure than 4.5 bar. So the task of this valve is to restrict the oil pressure. Also, when you run very high RPM, you don't need more oil pressure than 4.5 bar. Then this valve basically kicks in and it limits that oil pressure. And there is a certain design flaw in this valve. And that is the point where the oil pressure is measured. Measured is the wrong word because it's a mechanical control circuit what we have here. It basically takes the pressure from the secondary side of the pump and it feeds it back into this pressure control valve to regulate it. So the entire regulation circuit mechanically is here inside this pump. And what's actually getting to your main bearings is a different story. So what they did is they closed the circuit in a different way. They actually drilled this port back into the oil pump, and now they measure the oil pressure to regulate the oil pressure here based on the pressure of the main bearings. And that's a very smart idea. And you can see that on the newer oil pump, that there is actually this port. That port here receives oil pressure here from the main gallery, and it feeds it back through a couple of channels to the mechanical oil pressure regulator. So when you fire up this engine, it will not immediately limit that pressure down to 4.5 bar. No, it will start to limit it down once it reached actually the main gallery. So I really think that's an improvement what they did.
Okay.
Did I say that out loud? Yeah. Okay.
So was that now BMW or Ford?
I only said BMW because they used pressure control valves in their engines already forever.
Okay.
And other than that, BMW has absolutely nothing to do with this engine.
Of course,
Okay?
because we're going to get so many comments. Oh my
Yeah,
God.
there will be comments again. Oh, isn't that actually a BMW? No, it's not. Okay, it's a Ford engine built in Dagenham in the UK, and they make this diesel engine since 2003. But remember, the reason behind all of this is to increase the fuel efficiency of the vehicle, to get the EU6 rating on it. And all these measures are there to reduce oil pressure when it's not needed by the engine. And reducing oil pressure is always a compromise, okay? And it's always driven by fuel consumption. So is 5W30 and 0W20. Going down in the viscosity of the oil always means the manufacturer wants to save energy. That's the only reason. There's no other reason to use a thinner oil. So when you have these smart people in the UK in certain Facebook groups telling you that they tested all this and they figured it all out, and that's why they use 5W30, they're wrong. The reason they use 5W30 is they want to reduce the fuel consumption of these vehicles. And all these engines run just fine with 5W40, but they need those additional 1 or 2% of fuel savings in order to get the EU6 sticker. It's as simple as that. And then when you have these people telling you that they did so much testing and they had 50 engines running side by side and they tested different oils and they are so great and they invested so much money, and how can you say 5W40 is the right oil when they know the 5W30 is better? It's a very simple case. They already knew that they're gonna run 5W30 before they started the testing. The instruction to the test lab were, you guys gonna figure out how long the engine runs with 5W30, and if it gets us past the warranty period, that's what we're gonna run. That's how the decision is made.
I had a viewer write me a comment that he talked to a Land Rover's tech, and they designed the engine to last 150,000 kilometers.
Well, I think that's a wise idea because it gets you through the warranty period. Okay?
Yes, those engines are not designed to last 400,000 kilometers.
The design lifespan of a typical combustion engine in a vehicle like this is indeed 150,000 kilometers, but that's like the minimum. You can easily get them to last a lot longer by doing additional work and doing additional maintenance. Even a Toyota Land Cruiser is only designed to run 250,000 kilometers.
Yeah.
But 250,000 without any failure. And in order to reach that goal, the vehicle easily achieves then also 500, 600 and 1,000,000 kilometers. Because there's absolutely no tolerance for faults below 250,000 kilometers. So really good point.
And that's also the reason why we do not have any Toyota diesel vehicles driving in Germany, at least not the big SUVs, because those Toyota engines do not fulfill the EU6 requirements we have here in Germany.
The bottom line for us is we can't buy old Toyotas because we can't drive them. So the camera is adjusting the darkness up and down. I think it's really dying slowly. I had that already in the last video, but we anyway just talking, okay? I can talk in the dark too.
Yeah,
Not
exactly.
a big deal, but we're gonna get a new camera.
I don't see anything, but I hear.
No, it's inside, but we hear it clearly, and it has a distinct click to it. So I would say
This solenoid is functioning.
Tell them, what did you buy there?
It's a little power supply to diagnose the fuel burning heater of the Queen.
Ah, exactly. So that is still an ongoing project.
Yeah. I checked everything, every sensor, every system, everything is perfect, but the Queen doesn't turn on the fuel burning heater. Yeah.
Here we've got everything taken apart and put into our shelves, and now we are kind of stuck. Yes, and we are not able to buy a new short block, which was our worst case scenario.
Once we discovered this hole, our idea was to buy a short block. That's what it's called in English. In German, it's called a Rumpfmotor. So that's everything basically above the oil pan up to the cylinder heads. It does not include the cylinder heads itself. So it has the pistons, the connecting rods, and the crankshaft, and maybe a bunch of seals. It doesn't even have an oil pump from Land Rover. This Rumpfmotor was quoted by Land Rover for the Gen 2 with 8,472 euros on their website. But guess what?
Not available.
Not available and no date given. So that option is off, and right now we're stuck. The other thing I wanted to talk about now is how do we deal with this situation, okay? We got a little hole in our engine block and we need a little bit more stuff than just a crankshaft. Of course, like everybody would, I searched the internet for a Gen 2 engine block, and guess what I found? I found all the stolen cars out of the UK.
Unbelievable.
You guys the phone number from the guy, okay? It's so easy. They all sold in Germany over a platform called eBay Kleinanzeigen. eBay sold it, and it's now only called Kleinanzeigen again. And that platform is also an internet-based selling platform like Craigslist, except they do not trace the sellers. There is no payment method set up where you pay through that platform. There is also no insurance set up. You can't go somewhere and complain if something goes wrong. You are fully liable for what you do. And that's where you usually have sellers who have something to hide, okay? If it has to do with taxes, if it is stolen, stuff like that. That's sold over this platform in Germany. And that's where all the engines are out of the vehicles stolen in the UK. I mean, I give you guys the phone number from the guy. I put it right here in the screen and you can call him up. Call him up on this phone number and ask if he's got a TDV6 SDV6 3-liter engine. And then he goes, okay, he doesn't speak fluently English or German, but you hear his accent. It's out of a certain area in Europe. And when you ask him about that engine, he tells you, oh, it's a 2018 Gen 2 and it has 10,000 kilometers on it. Now, don't do the mistake and ask him, how can that be possible? Because then he gets immediately annoyed and he hangs up his phone. So it's really funny. And every single one he sells is less than 15,000 kilometers on a vehicle which is 5, 6, 7, 8 years old. So those vehicles, they must have gotten stored somewhere, okay, in a safe place. And then they took it out, crashed it, sold it to this guy, and he took the engine out and he's ready to sell it to you.
Yeah, that's what happens with the right. Because why would you steal a right-hand drive Land Rover and then sell it all over the world? No, they are only interested in the engine.
But I gotta say, okay, I'm addressing this to our UK viewers, which we really love, okay? And we're really sorry that your cars get stolen. You are on an island. You got a tunnel and you got containers leaving that island. What's your police doing? Why do they not handle this? How can those vehicles get off the island, end up in Poland, and then the engine gets taken out, inserted into the web page Kleinanzeigen in Germany, and then they sold for about 1,500 to 2,000 euro below market price. But they also have the advantage that they all have less than 15,000 kilometers, okay? That is really making them the exclusive offer. Oh, and by the way, when you call up the guy on one of those phone numbers I showed here, don't do the mistake and ask him if he can provide the VIN number from the vehicle where the engine came out. He hangs up again, okay?
Yeah.
I also asked if I can drive there with Vera to look at the engine, and I did that in writing, and the reply was, no, see pictures. Okay, sorry that I asked, okay? And it works the following way, according to their ads. You just tell them what engine you want. They will actually deliver it to your doorstep, and then you pay the driver in cash. That's what it says in the ad, okay? In Germany, the country with the most regulations possible. You have this entire network of illegal engine trading going on in a German trading platform. Really unbelievable. I'm completely stunned by this. But if you guys want to know where your vehicles go, a large percentage goes right there, and then only the engines come back into Poland, and from there they get sold back into Germany.
So, but I want to say also, for those comments we get, and we do get quite a few, why don't you just use the engine of an F-150?
The F-150 2018, for example, the Lariat, used the same 3-liter engine as we have here, but with one turbocharger. And that's the crucial item. The engine crankshaft, the pistons, and many other components in the block are the same, but the block itself is different. You don't have certain ports on the side, and you also don't have the provisions for the engine mount. So if you get an F-150 diesel engine, it won't fit, and you can't convert it. It's really a different casting. It's not that you can machine in the missing holes or something. That's of course what I looked at. No, it don't work. It's a different engine. And it really sucks because the F-150 engine in the United States runs between $4,200 US and $4,600 US, depending if you do a core deposit or not. And that tax and shipping included would still be far below 8,000 euros, and you would actually have an engine with cylinder heads and timing installed. Really good deal in the States. No reason to complain there about price, okay? Just as a side note. I printed out the pictures of an engine I found over there, and the guy was nice enough to do detailed pictures for me. And this is a 3-liter, exactly like this engine block, and it has different gussets here, and it is missing holes, and it is missing also the port for the second turbocharger. So absolutely no chance. I think Ford did this actually on a purpose, okay? They didn't want to have that trading between the UK and Poland, also including now suddenly the United States, because they're also on an island.
Well, I'm mad at Ford right now anyway, because we watched Le Mans. It was awesome, except for the vice president of the Ford company.
Yeah, and the Ford guy himself.
Yes, and the Ford guy. The Ford, the second. Yeah, so I'm still mad about those guys.
The Americans sure know how to make a good movie.
Oh my God. We also watched Ferrari recently, and that is also an incredible movie. And I love car movies. It's unbelievable.
Okay, I don't want you to film me when you flirt about car movies, okay? What I absolutely don't want is an engine where somebody else already did the overhaul.
Yeah.
I don't want to spend the money on it, and I don't want to have anything to do with it, because this engine clearly showed how many dumbasses are out there. You can't trust anybody. At least I can't trust anybody. I gotta do this myself. Now, another thing I wanted to talk about is the oil change and the oil type of this engine, okay? They added an additional problem, and that problem is severe oil dilution. Oil dilution has been a problem in previous engines running a DPF, but it is much more extreme in the EU6 engine. And that can be counteracted with good and frequent maintenance. And if that is not done, if you do poor maintenance, like every 30 or 35,000 kilometers, you do your oil change, you will have basically an oil in your vehicle which is no longer a 5W30, it will be like a 5W20 or even lower. So that's one big contributor of this failure mode, with the big ends seizing up. And you can counteract this. Just do your frequent oil changes. On our engine, which we bought, I printed out the service history from Land Rover based on the VIN number. There's actually a little website you can go from Land Rover, you key in your VIN number, and you get your service record from Land Rover. It's free and public, and everybody can do that. When I did this, I found out that this vehicle had, over the course of 135,000 kilometers, exactly 3 entries. The initial inspection, when they first got the vehicle to the dealer. The second one, when they changed the timing belt on it. When you checked out our last video, you saw how they screwed that up for sure. And they also did an oil change. That was around 95,000 kilometers. And then it had another service at Land Rover with 115,000 kilometers. So 3 services. And then the engine died with 135. Now, I'm pretty sure they did change the oil in between, but they did not change it frequently enough. I want to show you that there is a misconception of how often you should change the oil on these vehicles. Most people think that Land Rover specifies an oil change interval of like 24 or 25,000 kilometers. And that's absolutely not true. That's the maximum distance before they want to see your vehicle again. Otherwise, your warranty is voided. But if you look at their specification, they actually improved this significantly between the 2.7 liter TDV6 up to the 3 liter TDV6 SDV6. The oil change interval originally on the LR3 was indeed 24,000 kilometers.
Or 12 months.
But when they went to the 3 liter, they reduced this down to 13,000 kilometers and 6 months. Then they also included more language about the arduous use conditions of these vehicles. Arduous use is defined by Land Rover as towing, driving in mountainous conditions, wading, rough or muddy roads, makes sense to everyone, but also high-speed driving, Germany, yeah, hot or cold climate driving, or short distance driving.
That's what I do.
Hot or cold climate is not your minus 40 degrees and your plus 60 degrees like you would think. No, it's below freezing temperatures and above 35 degrees. That's already hot or cold climate. And then short distance driving is every distance below 25 kilometers. So under those arduous use conditions, Land Rover in today's times actually specifies an oil change at 6,500 kilometers. 6,500 is the minimum you can always do, and 13,000 is the maximum for arduous use. So the word on the internet is typically do your oil change every 10,000 kilometers, which is right in the middle. That statement is true. That's also how we maintain our vehicle. But what is not true is that Land Rover says every 24,000 kilometers. That was years ago. That was like back in 2008 or 2009. Since the later ones came out, the SDV6 coming out in 2011, it was already 6,500 to 13,000 kilometers. So it's not really their fault when people drive around with 25 or 30,000 kilometers without an oil change on these engines. Then they suffer from severe oil dilution and they run 5W30 in them. Obviously, that's what's specified. And then they get a bearing failure.
Yeah, and I actually stress Christian after 8,000 kilometers.
Yeah, because by the time I do it, it's then 10,000, okay? And, you know, this got to ripe a little bit, okay? It needs to be still kept a favor when I'm doing something on her car. If I would always immediately do that, okay, that's not how you teach her. By the way, we do have on our Patreon page a oil change interval table here in detail. I can show you that right here, but it's specifically made up for the 2.7 liter LR3 engine, and you can see how we change our fluids and what we put in. We use certain oils based on our experience, but it is not our job to tell you what oil you use, okay? There are plenty of smart people in the Facebook group, and you can ask them and you can get a predictable answer from them what oil to be put in. Land Rover recommended specification. That's the answer. I think that's it for this week's video. I hope it gives you an idea where we are with this engine rebuild. And at this point, I want to thank our Patreons a lot for their support. Also, please think about subscribing to our channel. We post a video every Sunday. And
we'll see you next Sunday.
Very well. Okay.
Hopefully